So welcome again to my YouTube channel. In today's video we are going to discuss about linear regression in machine learning. So we know that machine learning is one of the important branch of artificial intelligence that focus on the development of algorithms and statistical models that can learn from predictions. And in supervised learning we have classification, which is used to classify the data into various classes. And in regression it predicts the continuous output variable based on the independent input variable, like in prediction of house prices, certain weather forecasting and all such things. So we will begin with linear regression, understanding of linear regression. So it is a type of firstly supervised learning algorithm that computes the linear relationship, between dependent and independent variables. That can be one or more independent features. When the number of the independent feature is one, then it is known as the unvariate linear equation. So we have unvariate linear equation when number of independent feature is 1. And in this case, where if we have more than one feature, then that is known as multivariate linear regression. And the ultimate goal of this is to find the best linear equation that predict the value of dependent variable based on the independent variable. So we have to calculate dependent variable value to be calculated, which is based on independent variables. So for this we have an equation of straight line, which is equal to y equal to, let us say, mx plus c. So which is a straight line equation where we are having slope. The slope of the line indicates how much dependent variable changes for a unit of independent variable. Suppose this straight line is changing, it means it is identifying the values of dependent variable changes from a unit of time. Linear regression is used in many different fields, including finance, economics, psychology, and many other fields. So let's understand about this example in detail in linear equation, which is, suppose I am calling this equation as y equal to alpha x plus c, or you can call mx plus c. So where this value basically stands for slope, and this we know this is the intercept value in the case. And the equation along x-axis and y-axis is drawn like this, where certain data points are lying around this line. It is giving that how best this line is fitting these equations. And now in this case we assume that this x is, suppose, marks of the student. This is marks of the student. What? Value of x. Now this alpha turns out certain weightage of the values, some coefficient is there, and this is intercept, just like in any mathematical equation. So based on that we can get the aggregate value for this x. So now suppose we say if the students marks are changing up to, suppose, 550 total marks is there, then based on that we consider whether the student is going into which particular type of grade or anything. Or like, suppose age is a variable which is an independent variable, and we consider a dependent variable. Let us say this dependent variable is telling us probability of occurrence of a disease. Let us for simplicity call this as disease parameter, diagnosing the disease. So it is for, in this case, suppose this is the disease, and we say if someone's age is 50, then we will predict whether the result is positive. If age is 52, Suppose this is positive, this is age is 53, this is again positive. Now suppose age is 18, result is negative, and so on. So now based on this we train the model with these values, and now the question comes, age is 49. Here this is the question. So based on the previous training of the model with these parameters, where the value of x in this case was age, so we predict whether that patient has the probability of positivity or negativity. Now suppose this is positive case. So this is how this linear regression is working. Now here we have considered about simple linear regression. Now we have another type of linear regression, that is known as nothing other than multiple linear regression. So in multiple linear regression, the equation looks like this: alpha 1 x1, alpha 2 x2, alpha m xm, and so on, where this alpha I is considered as regression coefficient, this xi is my independent variable, and yi is my dependent variable, or we can say this y is output variable and this xi is my input variable. So in this case we can say, suppose this x is again age factor. Now this x2 represents suppose diabetic result of the patient, and x there is some other parameters like xm suppose stands for gender. Now based on this, what is the age of the patient and whether that patient is diabetic or not, and maybe male or female. So based on this we want to calculate what are the chances of getting the disease for a particular xyz person. Let us say we want to calculate for person number suppose 10, and from we trained the data, we have trained the model with these parameters, the existing values. Suppose 9 patients data is there that has been trained, and we want to calculate for 10th patients, we want to make the prediction. So in that case, based on these parameters, it will predict like age, diabetic, and gender. Based on these multiple parameters, it will tell the result for this y, whether that is diabetic or not, or what is the probability of getting diabetic. But when we discussed about the other thing, that was simply simple linear equation. In that case, what we were doing, we were simply checking y equal to alpha 1 x plus alpha naught. Fine. So this was how we have worked in simple linear regression, where we were working on a single value like age. In that case, in the previous example we have considered, and here we are talking about the multiple values. So now we have to check which is the most probable variable for getting the result. Most important, we have to find most important independent variable we have to check. Now suppose we are having values like 0.9 for here, plus 1.2, 1.2 plus 2 plus 4. So this is the highest value. So we say this x4 is the most important variable. So this is how we work in linear regression. In the next video we will discuss about logistic regression.